Recording in progress.
Hello.
Hello. Hello. Yeah, I can hear you. Okay, let me check if that is everybody. Yeah, that seems to be everybody. Well, then, is everybody ready for the training, or should we wait for a little bit more?
We can start the training now because Hassan is away, so it's just three of us.
Mm-hmm.
Okay, so we can start the training.
Okay. And let me share my screen real quick. Okay, my name is Alexander. I'm from the UGC support team, and today we'll be learning the basics of UGCS, but most of it, well, it's most, I would better call it fundamentals, because after this session, you should be able to do almost everything you want in UGCS and how to control your drone. Can somebody tell me what is your primary application for UGCS? What drones you're flying? What are you trying to achieve with it, so that I can more focus on the tools more needed for you?
Okay, so the reason for why we buy the UGS system is for magnetometer survey, and we also plan to add another LiDAR survey in the future. But right now we want to know how the system works, and especially for the trend uh, following and etc. I mean terrain following.
Yeah, I get it. Okay, I have a presentation with me so that we don't get off topic too much. Okay, in the basics course, here are the topics that we'll be discussing in most detail. So the usage of UGCS documentation and how to contact me and my colleagues at the support team, the system requirements and how to license, install, and configure all of your components needed for UGCS. Then is the user interface. We'll go, this is basically the biggest section because there are a lot of tools. There are a lot of little things in UGCS that might be useful or not, but we'll be learning most of them, so that if some tool fits your fancy or your application, then you'll know where to find it and how to use it. Then are the flight planning tools. Of course, we'll be learning how to use the waypoints, the photogrammetry tools, LiDAR areas and corridors, and many more. What we can do with routes, how to use Maple Innovation data in UGCS, how to import, how to export, how to use different altitude modes to use that elevation data effectively. Then is the telemetry player. Well, I'll go through the various export options, including the telemetry player, where you can record all of your telemetry and share between fellow pilots. Then I'll talk about the UGCS for DJI app. As I understand, you're using the DJI M300, right? Well, if you'll be using a different drone, then I might tell about a different app, but they all use the same principles. How to use UGCS offline without an internet connection, since a lot of our missions go through they happen in very remote places, so internet is not always available, and how to use UGCS Mapper. Here are the various sites with documentation that you'll need to check out. The most important one is the manuals at .ugcs.com. This is basically our manual website, and if you can learn to use this resource, then you might never need to contact us at support again. Here are the various apps that we use, but the most complex one is UGCS, of course. And if you have a problem with, all right, your license, you don't know how to deactivate your license, well, you can search the topic you're interested in using such keywords. For example, something related to return to home, and these are the ones. Well, there should be more. So I really recommend after this lecture, well, after this course, try using UGCS on your own and try using the resources mentioned here. Of course, the integrated website where you can download all of the software needed for Sky-Hub connection, so that all of the hardware is interconnected. But as I understand, you'll be having a separate GPR training or magnetometer training. I'm sorry, and more details how to use the software will be in that course. And of course, the SPH engineering support, the website where you can leave a form, or here's our email. I work from 9 to 6 p.m. Riga time. And if you have any questions, in order to waste less time, please attach some log files, some screenshots, maybe even video recordings of your issues, and send us the UGCS mission so we know where your problems come from. And of course, your license code so that we know you're an actual customer. The system requirements of UGCS are really basic. They're written here, but knowing that UGCS usually handles a large amount of data and visualizes it, the most important two factors in good UGCS performance is having at least 16 gigabytes of RAM. It will work on 8, no problem. But the more RAM you have, the more data you can import into UGCS. Because at some point, you'll learn how to use UGCS effectively and build missions that last hours and hours and hours. And also, a dedicated GPU will be nice, because UGCS is a 3D based software, and the visualization can take a toll. And an SSD, of course, will be beneficial because, again, of the large data size. Reading it fast is important. In order to use UGCS, you need some sort of Wi-Fi router in order to connect the various apps to UGCS. That can be a mobile router you can buy somewhere, or even use the hotspot from your phone, even the RC, or from the laptop itself. But you don't really, well, in most cases, you don't need to connect UGCS directly unless you want to record telemetry and modify the missions on the go. And also, since UGCS uses the common network of your devices to connect all devices, your firewall or any antiviruses or other network security protocols should allow the following addresses, ports, because UGCS takes a lot of data from the internet, mostly, well, it's basically map and elevation data, and we'll go through a workflow how to live without that data, but initially we need it. So the most important one is the activation server, so you can activate your license. You only need to do it once. So theoretically, you will need internet with UGCS just for the activation, and there are many workflows to work offline. And of course, if you're using a Wi-Fi network, then the network should be set as private. So if you have any connection issues, then ask your network administrator to check what is the network type. But there are always workarounds, so you shouldn't worry about it just yet. And of course, UGCS works on on all three systems, so Windows, Mac, and at some capacity Linux. When you're installing UGCS, you're installing various components, since some people need more functionality, some people need less. But the mandatory ones are the Geo server. This server handles all of the geographic and map information within UGCS. The UCS server, this is the component that connects all the drones together and links it to the other components. The UGCS client, this is the 3D engine that works and shows all of the data in a nice visual way. And the vehicle support, these are separate components that you can install if you're planning to use a specific drone autopilot. So in this case, support DJI vehicles, but this is the VSM that's mostly for newer DJI drones, so the ones that are using DJI Pilot 2 or UGCS Companion. Usually, the M300, for example, can use both UGCS for DJI and DJI Pilot and UGCS Companion because it uses both old and new SDK. But the DJI M350, that will only work through DJI Pilot or UGCS Companion. So you need to add the support DJI vehicles component, as well as custom drones using the ArduPilot PX4 autopilots. You need to install a separate VSM for that. And when you're running UGCS, all of the components are running, as for example, in my case, I have UGCS running, and you can stop, restart, and run all of the components using the service manager. For example, if your maps aren't working, try to check that the Geo server is running, and if it's not, then start it, or just try restarting it, as with all other VSMs. The first step when working with UGCS, you should activate your license. It is done here in the top right corner. Here you enter your activation code and activate it. Since UGCS allows one or two activations, you can deactivate the license on, for example, this computer and then activate on another one. but use of only a single license allows you to use the code at one device at a time. And of course, if some issue happens, for example, the uninstaller should deactivate the license automatically, but software is a very fickle thing. So you might, for example, not deactivate the license, or your computer bricked, or any of these issues that may happen. Why you can't deactivate your license? Then you can send us your code, and we will reset it for you. Now, the user interface, we have a lot of things, but they can be divided into manageable chunks. And excuse me. So let's go in a clockwise direction. First, we'll start with the with the menu of UGCS, where we can access the main menu, where we can create missions, open missions, delete them, and export them. The first, I would like to explain that missions are basically the overall project of UGCS. So the mission is, for example, the window of a Chrome browser, and the routes are individual tabs, and you can create multiple routes in a single mission, but not the other way around. But missions contain more information than just routes. They contain all the NFZs, the drone profiles you're using, and stuff like that. So if you're planning a very large scale operation, do it inside of a mission, and name it something, and export it. And all of the routes, everything else will be saved within it. If you want something specific, for example, you just want to fly one thing, one route with one drone, then you can save here the route instead in multiple formats. I'll talk about them a little bit later. So the next thing is the route section. You can create new routes by clicking here. Or when you create a mission, the first thing that will ask you is to create a route from scratch or import from a file. You can import KML files, CSV files, and maybe one or two other formats, but I recommend sticking with JSON and KML, since those are the industry standard between tools that we usually use. So if we create from scratch, we can set the name and select the drone profile. For every supported drone, we have a drone profile and more, because PX4 and AutoPilot are custom. Well, those are autopilots, and you can connect a custom drone. So, for example, if you're using the M300, you can see I have multiple options in here because the drone profiles can be configured very differently. But I'll use the default one. This is the tool section. This is where most of the magic happens. So we select a specific tool, double click or shift left click the mouse button, and we can create our waypoints, our areas, and everything else. As you can see here, we can see the segments that we're adding, and in this section, we can also move them between positions, and the route will be recalculated. And at the bottom, there are even more tools, but we'll get to that after the interface. At the bottom left, we have the compass. So you can click it and it will reset to the geographical north. And right from it are the coordinates of our mouse cursor, as well as the terrain elevation. As you can see, it's changing ever so slightly, but there's a difference. And as well as the camera altitude, to make sure you're not viewing the map too far away or too close. Next are the UGCS logs. This window tells you about possible issues or about a summary about your route. So, for example, I'll make it do something impossible and make a route with a GSD of 1 millimeter. And as you can see, it doesn't allow me to do that and warns me about that in the 1, 2, 3, 4th segment. There's a problem why the route cannot be calculated. And it even gives me suggestions on how to change that. And even more, that okay, you, in order to make the mission that you want to work, you need to decrease the speed or make a smaller GSD, because the camera you have selected here cannot shoot that fast to get the correct overlap and so on. So these, so this log is very important for understanding what you're planning. And as you can see further, you will see a summary of your route. So the area, the size of the footprint, the number of waypoints and passes, and if you have an action added, it will give a summary on how it is working. On the bottom right is the drone logs. When you're connecting a drone to UGCS, this is the window that will show the various messages, the warnings, whatever comes from the drone autopilot will be shown here. So if you're, for example, having a drone pilot on site and somebody else is working with UGCS to monitor the flight, he will be receiving these messages on his remote, and the second pilot from UGCS will be receiving it here. So if we, for example, connect the drone, this is an emulator. As we can see, the first message is that we're taking off the drone, and a lot of various things happen. And if you're interested in using the emulator, all of the errors that came before it is because I uploaded once, the drone was relocated, and in order to upload it successfully, you need to upload it a second time. And then you can start the route. And nothing else should worry about us. Well, nothing else should worry us because the mission is already flying. But if something happens, if some obstacle sensor are triggered, or the autopilot says of something about wind or high temperatures, this log will also contain that information. The next window is the telemetry window. This is where we can see the various stats of our vehicle. So the battery, the GPS satellite count, the telemetry percentage, the RC signal. In this case, we don't have one, but when you connect an RC, there will be this level, and the various altitudes. So raw, this is the altitude from takeoff point, because all drones mostly use the barometer to understand its relative elevation. And the AGL altitude is the above ground altitude calculated from the elevation data in UGCS. So the AGL altitude value may be different in different flight apps because they use different data sets for elevation. And basically, this is the technology upon which the terrain following algorithm works on, is that you have a data set of elevation inside of UGCS and builds waypoints according to that, well, relative to that elevation data. And then since most elevation is relative to the takeoff point, the raw altitude, all other waypoints should be aware of the various obstacles and terrain changes. But of course, you can always purchase a hardware altimeter where this raw altitude will be the value of the altimeter. And of course, the MSL value, this is the measuring stick of all drone flights, and it should basically be all the same between apps. And it is also included as an altitude mode in our tools, but we'll get to that later. The ground speed or horizontal speed of the drone, as you can see currently, it's flying at 1 meter per second for some reason. And the vertical speed, well, up and down. We can also give some commands to the drone. The amount of commands we can give depends on the drone autopilot we're using. But from here, we can return to the drone to manual, click and go, use a joystick to control the drone, and command the drone to land or return to home. And well, depending on the autopilot, the amount of options may differ. If this amount of telemetry isn't enough for your flights, then you can click on Show All Telemetry, and all of the data that is streamed from the controller to UGCS is shown here. And here's our vehicle list. If you've connected a drone, then it should highlight like this, but sometimes they get buried away because we have removed them, and we'll need to add them back like this. We can, for example, double click the route card. We will be locked into the drone position. And if we're, for example, using a custom drone, from here we can select the profile which it uses and some features that you might find useful. For example, the show camera footprint for photogrammetries is pretty handy. Next is the, let's call it the view tab of UGCS. This brings up the route summary, but you can also do it here on the check mark. And this is not a feature that many people use, but you can, for example, save a viewpoint and load it back in. This is, I don't know about the specific use case, but I find it handy for presentations where I want to show a mission at a very specific angle. Here we can change between edit mode and telemetry player. I'll talk about it later, but this is for route playback. As you can see, the logs are all recorded, the telemetry is displayed. Oh, this is not a good route to show that. So after flight, if you have a desire to analyze your flight afterwards, then it is handy to do so within the UGCS video, telemetry player. At a later date, there we should have a turn off the flight mode where we will have the various planning tools removed and extended on more telemetry. We have removed it for version 5 because we thought that nobody used it, but as it turns out, a lot of people do use it. So we'll be returning it shortly. Next are the map layers. This is the command hub of all map and elevation 3D models, PlaceSmart. Basically, different map elements of UGCS. So from here, we can choose the default map which we're using. For example, I don't know, for some reason I have Bing, but from default ones, we can use Google, for example. And of course, upload custom ones in case, well, most of the satellite data is pretty outdated for any professional work. So we might need to update our maps and update our elevation, our terrain data, so that we fly with precision. So for example, this is a map made by one of our clients. And there are some quite a few differences. So having an accurate map gives you map awareness. As well as the elevation tab, here we can choose our different elevation sources. So by default, we use SRTM4, north of 60, and SRTM1. I prefer using SRTM4, but each location on planet Earth differs in the accuracy of these. Well, basically, for every region, there's a certain elevation map. You can connect the external ones through a WMS source or by uploading local files such as this one. I feel it's not a good representation. Yeah, it shouldn't look like this, but I assume that the coordinate system was chosen poorly, but at least you can see the difference that the elevation model changes within seconds. And of course, the drone will also
Ini
create
ada plusnya nih,
waypoints
saya
according
pakai.
to that data. Next, we can add 3D objects into UGCS. So using a photogrammetry software like Agisoft Metashape, Reality Capture, or 3D Zephyr, well, there are quite a few of them now. So you can fly, for example, a photogrammetry mission and import the model back so that you have a great reference to fly in more detail. But for terrain following, I really recommend using them in the elevation tab instead, because 3D objects contain, well, 3D objects are seen as obstacles, and depending on the model configuration, it might not do what you might need. Like, for example, with this model, as you can see, the waypoint, well, the waypoint is at a 50-meter altitude, which is a lot higher than the houses displayed. But if we look in the next section, the elevation profile, well, it doesn't show because it plans the two waypoints from it. But we use something like the corridor, which creates waypoints to follow the terrain. Okay, it seems to even exceed the altitude. If such message comes up, that means that the drone profile needs to be changed. This is the MU101. It's my drones. And here we can configure the various. This is in the route parameters. I'll talk about that in detail a bit later, but here are the parameters for the route. And as you can see, for some reason, this is just a modeling thing. The elevation of the 3D model is a lot higher than it is visually shown. In this case, here in the elevation profile, we can check the information about the terrain, the flight line, and any obstacles. In this case, the obstacle is at 687 meters from the ground, so quite a lot. Before the elevation profile, we have the search bar. This is the same as using, for example, Google Earth. We can type in an address or some geographical object, and quickly go there. We can also use coordinates. So, for example, we have the coordinates from this waypoint. We can add them through comma. Yeah, I think this is the same place. So you can, and also you can do that in both coordinate formats. So, for example, in Google Maps or Google Earth, this format is preferred, and you can use it in the same way. Next is the dark and light team. So this is for mission planning in the office, and this is for flight planning and execution outside. And this is the main user interface. At this point, I would like to ask you if you have any questions on the location of some features, or if you have any questions in general about the things that I've told you right now.
I want to ask you a question about can we add our data from our UTM that we got from writer for elevation model?
The audio quality is a little bit bad, but I heard the elevation model. So the elevation model is handled here in the map layers. So in the elevations tab, this is where you upload your DEMS.
So what is the format for we can?
GeoTIFF.
GeoTIFF.
Yes.
So
UGCS. Huh?
Can we import last file to USGS?
Import what?
Last file, like dot last file with command.
No, you can't import dot last files, but I think you can convert it with some software.
Pardon me, can you repeat it?
Once again?
Can you repeat again? So we can import last file to USGS.
Yes.
No, you cannot import LAS files into UGCS, but I imagine you can convert them somehow, or at least use it as a reference. What was LAS?
So not bootable as only LAS file.
LAS.
Yeah.
Like that?
Yeah.
So this is basic cloud data. So
Yeah.
for such files, you can use, for example, QGIS, or as mentioned here, ArcGIS, and you can export the GeoTIFF or the DEM
Ya,
in the
masuknya ArcGIS
GeoTIFF
atau
format
Google
from
Mapper,
there.
convert ke GeoTIFF dulu.
Okay, that means the only thing that we can import is the model, not the point cloud. I mean the model, not the, so we can import the point cloud, right? So you just said to me that we should try to process the point cloud become a model, so that's why it becomes TIFF, right? Yeah, okay, I get it. Thank you.
Well, you can always generate a GeoTIFF file from the point cloud, but UGCS on its own doesn't doesn't import point clouds, because at this point we don't think that we need to, because with the amount of data a point cloud usually has, visualizing all of it will take a large toll on the hardware. So we use these formats for just efficiency. Okay, do we have any more questions?
I think that's enough.
Okay. I'll continue using this as reference. So the flight planning tools in the left side of UGCS I mentioned are divided in 3 groups: waypoints, takeoff, landing, and at first waypoint we'll remove at some point because they're just waypoints and confuses people. The camera LiDAR tools, which are the most interesting, and the task-specific tools, so the area scan, circles, perimeters, and so on. But since you're flying with a magnetometer, I think the most important tool in all of UGCS is the area scan. So in this case, we'll get into more detail about that. So as I mentioned before, you can create a new route in UGCS, and the very first thing that you'll be shown is this window right here. This is the settings of your route. So aside from the name, you can choose the vehicle profile, so the drone that you'll be using for this specific mission. If you've got the wrong profile, you shouldn't worry about it, because when you upload the mission, it sees that the profile and the drone are different, and it will ask you to choose between copy, set the correct profiles, or do nothing. So the next parameter is the initial speed. If you're flying low to the ground, so 3 meters and down from the ground, I really suggest changing the initial speed, because this is the speed at which the drone goes from its current location to the first waypoint. I forgot to change this parameter, and I was flying 2 meters AGL, and 5 meters per second at that altitude is quite scary, especially with a lot of obstacles in the way. Next is the coordinate radius. This is the turn radius at which the drone turns, but this parameter is also copied to every tool, so you can leave the coordinate radius in the profile, in the route parameters as default, and change it in the specific waypoint or tool where you want to change it. Currently, it is set to default set in the drone profile. The takeoff point altitude, this is an important parameter because, as I mentioned before, most elevations, if you're not using most altitudes, if you're not using a hardware altimeter, are based on the barometer, and every single waypoint after that is relative to that takeoff position. In that case, we need to specify the altitude of our takeoff position compared to the digital elevation model. So, for example, we have imported our elevation model and decided to take off from our car, which is around 2 meters in height, for example. That's a big car, but maybe a bus. And the drone understands only in relative values. So in this case, all the flight altitudes, they'll be shifted by 2 meters because by default, the drone assumes that it's taking off from the ground. So in order to avoid this, we can set a positive or negative altitude. So for example, if we're taking off from a 2-meter bus, we add 2 meters. If we decide to quickly dig a well and take off from there, then we add a minus, for example, 2 value from there. Next is the return home altitude for the route. The altitude entered here is relative to the takeoff position, so keep that in mind. So this is not AGL. This parameter is sent directly to the drone autopilot, and drones do not understand AGL. They understand everything relative to the takeoff point. And not even takeoff point, but the point where you turn on the drone. So a little tip there, do not move your drone after you turn it on. Next is the maximum altitude above ground. Quite a lot of times, again, because the altitude is relative to the takeoff position, you might need to increase this altitude because this is above ground, but the drone understands from the takeoff point. As well, when you're flying, for example, maximum above the, well, if you're flying above the default 120 meters, which is the legal limit in Europe, for example, then you will need to increase the maximum altitude here in the route profile, well, here in the route parameters, then in the drone profile, then you can plan your mission. And when you want to actually fly the mission, you need to increase the maximum altitude in the drone settings in the native drone app. So for example, for DJI drones, it's DJI Pilot 2, or for older DJI drones, DJI Go or DJI Pilot 1 even. Next is the fail-safe actions. For most DJI drones, there is only a single one. Is the fail-safe in case you lose RC signal. For example, the emulator, which is based on ArduPilot, has a lot more fail-safe actions and options. But for DJI drones, the main one is loss of RC, and the options are to go home in case you lose RC signal, or to continue. Not all drones support saving the mission inside of its internal memory, but most newer ones have almost an unlimited amount of memory for waypoints, so you can continue flying even without a visual line of sight. Though that is a little bit legal, but there are needs. So sometimes we have to go beyond what is recommended. And the last thing is the zones taken into account. This is the no-fly zones in UGCS. And so, for example, well, UGCS has its own database of no-fly zones. As you can see here, this is our Latvian airport NFZ, which means that we have the following restrictions in this zone. And we'll later talk about that we can create our own NFZs in UGCS itself, so that we can create custom limits for drone pilots and drone flight planners. But of course, these are the NFZs for mission planning for UGCS. So if you're planning to fly in one, DJI has its own base of no-fly zones, and if you want to fly in one, then you'll need to get the permission of the NFZ zone owner or somebody from the government and provide proof to DJI that you can fly there. After that, they should give you permission pretty quickly, and you should be fly there, even though you should be allowed. Okay, now we'll talk about the specific tools. We'll start with the most basic but fundamental one, the waypoint. So as I mentioned before, you can double click or shift click to create them. You can delete them here and reorder them. As well, you can use Ctrl-Z to return and Ctrl-Y to redo. So the basics are that every waypoint has a coordinate, has a coordinate in latitude, longitude. You can change the format, and you can copy paste from and to UGCS. Next are the different tabs. The basic tab contains the altitude, the flight speed, the turn type, and the altitude mode. So when you change the altitude mode, then the well, this is what reference value does it use? Does it use the elevation data, for example, digital elevation model from UGCS, or the above mean sea level? So in this case, of course, you can use both depending on the situation. For example, you'll need to use AGL for terrain following, but there are times when you don't need to follow the terrain, you just need to fly constant altitude. In that case, we can use MSL. And for example, I want to fly MSL on all of them. I can use Ctrl-A to select all of the waypoints or even all of the segments, and I can change the values in all of them at the same time. And now they're all at the constant 60.63 MSL altitude. And next is, well, going back is the turn type. The turn type depends on how the drone handles the turn. And for DJI drones, there are two turn types: the stop and turn. This means that between three waypoints during a turn, or even at every waypoint, the drone stops and then turns towards the next one. That is very accurate, but pretty slow. So that's why there is a second turn type, the adaptive bank turn. In this case, the drone flies the turn continuously using the coordinate radius that you've set. So that's why this parameter is very important, so that you can control how the drone behaves during the turn. Do you want the turn to be tighter, or do you want to give it all the freedom it needs and not decelerate during the turn? And of course, ArcPilot and PX4 have different turn types, but they're basically two versions of adaptive bank turn. Straight waypoints turn inwards of yeah, they turn inwards between the waypoints and spline outwards. And of course, you can combine them.
Iya, makanya kan kalau itu dia berhenti dulu dia.
Next is the photogrammetry tool. This is an area type tool. So instead of creating individual waypoint, we create a region in which waypoints are generated according to the parameters set here.
Jadi kita tinggal bikin boundary-nya.
As you can see, it takes a while because
tinggal bikin boundary, langsung dia bikin line sendiri.
very unreasonable parameters, but does so anyway. So, for example, the first, of course, it has the latitude, longitude, and in this case, let's change the GSD. So the photogrammetry tool does not use altitude because we use the GSD.
Ada ini side overlap-nya ketahuan.
The GSD, UGCS calculates the altitude needed to capture that GSD. So in this case, for a GSD of 5 centimeters per pixel, it's flying around 91 meters AGL. And if we change it to 1, for example, it should go lower. Yes, 18 and 19 meters.
Rapat itu 1 cm. Makanya jadi rapat banget ininya.
All of this data is referenced to the camera.
Dalam cm kan?
To the camera profile. So we have profiles not only for the drones but for the camera as well. I'll show you later how to find them and create them and change them. But basically, if you use for example, M350, you'll have a different collection of cameras. These are the most popular ones, like the L1 camera, for example.
Bikin jadi KML,
and
nanti
it will calculate the route differently depending on it. Next is, of course, the flight speed. This speed is set to the entire region. So for all of this grid, it will fly at 5 meters per second. And the overlaps, of course, the forward and side overlaps, these are set in percent. And changing them will also change the amount of flight length. Again, the turn type and the altitude mode. And as you can see in the photogrammetry tool, there's an additional smart AGL altitude mode. This is AGL, but in all directions. So for example, I think I have a slide showing this. Yes. So AGL looks at the elevation model straight down, while Smart AGL looks at the nearest surface. So for example, if you're flying in very challenging terrain and if the drone is looking only for the data downwards, then it will just crash into the terrain right before it. But in this case, this will be avoided because it's aware of the terrain in all directions. And of course, the rangefinder, this is the altimeter altitude mode, and this will be flying the route according to the altimeter on the drone. In the advanced tab, well, the waypoint also has an advanced tab, but there is only the corner radius and avoid obstacles or terrain. But in the photogrammetry, there are more parameters. So in this case, AGL tolerance. This is the amount of waypoints generated for terrain following. Let's go a little bit more challenging.
Fotonya ke kamera aja. Ini nggak nyontohin buat bakal bak nimbusnya.
Tapi yang penting bikin rutenya dulu. Jadi ya ini
But
itu
not too
rutenya doang kan.
challenging.
Yang penting kan nge-generate rutenya dulu. Nanti masalah nimbusnya di loggingnya
Okay,
belakangan.
this looks like a nice
Ya,
mount.
ini. Ini kan sebenarnya bukan masalah foto enggaknya, ini kan sensornya bisa diganti.
Okay, a little spoiler here. This is the double grid.
Kamera
Defense
gitu, kan nggak
radius.
langsung bak nimbus gitu. Kan nggak ada sensor foto.
It seems this is a pretty big area. So we have, you can turn off and turn on the double grid. Sometimes you need it, sometimes you don't. But for mapping purposes you don't, but for 3D models, a double grid is useful. So AGL tolerance. This is the amount of waypoints generated. This is the threshold of terrain changes. We generate an additional waypoint. So at this stage, it is set at 5-meter increments, and we have currently 681 waypoints. But we can change the tolerance to, for example, 1 meter, and will increase the amount of waypoints to follow the terrain more precisely. But this is not the parameter that should be overused, because the more waypoints you generate, the more waypoints you have. Well, I mean, every waypoint has a specific command, and if you generate too much of them, then the drone autopilot will stop between them, because at every waypoint it receives a new set of commands,
Karena dia
and
loading
only
waypoint
after
tiap
reaching the waypoint it can execute.
bisa terlalu
And with too many waypoints close to each other, it will keep stuttering.
sih ya nggak masalah.
So in this case, I recommend increasing the AGL tolerance. For example, the DJI Pilot uses around 10-meter AGL tolerance, well, based just on observation. Next is the direction angle. This is the direction of flight. You can also configure it here, and basically it shows from where to where the drone is flying. So for example, in this case, I want to fly from the left bottom corner to the right bottom corner, and will generate the flight as instructed. Next is the overshoot. This is how much the flight lines extend beyond the area. So in a perfect world, we'll set it to 0 and we'll capture all of the data that we've set it to do. But sometimes we have very specific, a specific area of interest. Or for example, a client has given us a KML file, and the area was important, but we practically understand that we need to capture a little bit more data outside of the region so that we don't lose that data during turns. In this case, we can add an overshoot. And in case of what we do during those overshoots, do we gather data or not, we can change the overshoot speed. So for example, with a magnetometer or GPR, we might not need the data from the turns, so we can just increase the speed and get over the turns faster. Next is the action execution. So as I mentioned before, every action the drone takes, it takes those commands from a waypoint. Since this has generated waypoints, we cannot modify each waypoint individually, but we can choose. Yes.
I want to ask about the AGL tolerance since we mainly use this drone for magnetometer surveys. You said that if we use too low tolerance, it will create more waypoint for the drone. Meanwhile, for magnetometer survey, we want to stick as accurate as possible to the ground level. So, what's your recommended value for the AGL tolerance for magnetometer survey?
I cannot say with the. First of all, are you planning to use an altimeter?
Okay, but because for
No,
the
no.
magnetometer surveys, we have to fly at constant height above ground level. Because if there's a slight deviation between the ground level and the anomaly below, we might result on biased data. So it will give low response, but the actual anomaly is not there. It's just because there's a slight difference between the altitude of the drone and the actual ground level.
Mm-hmm. Well, in a perfect world, we would just use a radar or laser altimeter on the drone, and then with the rangefinder altitude mode, the altitude will always be constant. So the AGL tolerance parameter it isn't even used at that point.
So if we
Uh,
have the laser altimeter, we can set the AGL tolerance to 0.
no, you cannot, but the you see, you don't want to set the AGL tolerance at 0 or anywhere near it because it will generate too many wavepoints, as I mentioned. So, for example, here's an AGL tolerance of 1 centimeter, and okay, the amount of waypoints isn't so drastic, but because of the nature how a drone works, for example, these 3 waypoints, you may introduce that. So, for example, we have a specific speed set on these waypoints. So every waypoint has a flight speed of 5 seconds, 5 meters per second. And once it reaches that waypoint, well, it cannot get such speed going to the next one. So it will either UGCS will make adjustments to slower the drone, or the drone will do it for you. But that is more unpredictable, since the drone likes to receive specific commands which are possible and then execute them instead of receiving unreasonable demands and then trying to execute them. And so for AGL tolerance, actually it is a balancing game. Of course, you want to make it as low as possible, but if you have too many waypoints, the stutter will decrease the quality of your data. So in this case, just adding one of, for example, 3 meters is already going to provide a more stable flight, which will provide with more quality data. So in this case, depending on the product you want to get, you'll have to choose personally. Uh, when, as I understand, you should receive magnetometer training. During that, well, the lecture, well, the trainer will tell you about the specific parameters that can be used for each specific sensor. But at this point, I can only tell you about UGCS in general. So write down that question and ask during the next training.
Okay, thank you.
At this point, now we're learning to control the drone to the best of our abilities. So if you want to fly with an AGL tolerance of 1 centimeter, you can do that, but there are consequences. So talking about the waypoints and their actions, here's the next parameter, action execution, and here we can check it. We can choose where the actions are executed. So usually use every point and we'll be fine. Oh, but sometimes you only need to use it at start, like for example, LiDAR actions, or when you were recording video, we need to do the action just once, and then at some point stop it. And at forward passes, so this means the actions are only during the main flight, and the turns don't have an action. So of course we have the double grid, which is disabled. You can turn it on or turn it off depending on the mission you're doing. Additional waypoints creates actual physical waypoints according to the actions used. So for example, the photogrammetry tool has a set camera attitude action going nadir with the camera by default, and set camera by distance. Right now it is set at auto, but we can set it manually. For example, I want to take a picture every 100 meters, and this parameter will create additional waypoints for that action. Or for example, without additional waypoints, we have 313. With additional waypoints, twice as much. And avoid obstacles, and camera top facing forward. This parameter is mostly used for those people that fly the drone sideways. So for example, for solar panel inspections or for power lines, you don't need the drone to follow the flight lines. In this case, they set, for example, I'll talk about the actions later, but this is a good introduction. So we have the set camera the drone yaw. In this case, we can set the yaw relative to the next waypoint or to north. So let's imagine that we set the drone yaw to 0. North is, as we can see up here. So in this case, the drone will fly all of the lines perpendicular to the flight lines, and it will stay that way even during turns. So the drone heading won't change at all. But this will introduce a problem that the drone is flying in a 90-degree change. So how are the side and forward overlaps are switched? In this case, we understand that, and we can just write the forward and side overlap switched. But in case we don't want to do that, so we want to remain, for example, 80% forward overlap and 50% side overlap, and I don't want to make the adjustment to switch them around, I can use the camera top facing forward, and then the camera settings are calculated as it is switched from landscape to portrait. And this is the actions tab. I didn't mention it in the waypoint, but we can set it in every tool of UGCS. So as I mentioned, by default, the photogrammetry has the set camera attitude, and the tilt is set at 90 degrees, so it's looking straight down. So that means at 0, it will be facing forward. And you can also control the camera roll and yaw. And if you really want to, the zoom level as well. But I don't recommend using this parameter. Well, you can use it, but you'll need to do some calculations on what is the zoom level compared to the focal length. So in this case, I don't really recommend setting the camera attitude at the photogrammetry tool, because it will set at every waypoint, And in some cases, if you're using adaptive bank turn, the drone turns, and during the waypoints, it will set the gimbal at an offset. So in this case, to get constant photo data, I recommend setting the set camera attitude with the tilt at 90 degrees, for example, and then fly the photogrammetry area or area scan without changing the camera tilt, because it was locked in at the previous waypoint. Next is the change yaw. So 0 is forward. Well, relative to north, it's understandable, but to next waypoint, well, it's also understandable. So it doesn't go into negative values. It goes from 0 to, 360. I imagine you can set more, but there's no point in that. Next is the default set camera by distance. So you can set at what distance is created a new waypoint for to take a photo, or you can use auto mode, and it will calculate based on the photogrammetry settings where to take a picture. Usually it works just fine. And since there is a set camera by distance, there is also set camera by time action, which works in the same way. You can leave it as auto or set a specific interval. And of course, if you're setting an unrealistic interval, okay, this is not an unrealistic interval, but this should.
Terus ya.
No, there is.
Memenuhi memori ya.
So as you can see in this specific mission route, the change was the flight speed was changed slightly because of all these waypoints, which doesn't allow for normal descent. As you can see, the max descent speed
Kayaknya pakai yang nomor 2 deh.
was exceeded.
Ini kan tadi
So
nge-generate line-nya pakai yang lain, yang tool nomor 3 kan yang ada P-nya.
lower the
Kayaknya yang di
altitude
bawah itu
and get
yang cuma bikin rutenya doang, nggak
and
pakai
let's get to the
photogrammetry.
correct elevation or altitude more
Kayaknya si L
accurate.
tuh leader, jadi
This is the exact reason why we don't want too many waypoints, because with the constant elevation changes, well, the drone has its own hardware limitations, and it cannot get this close and this high up that fast or smoothly. And doesn't say anything about the camera. What camera shows the Jason Usil 1. Okay, it seems there are so many waypoints that it can actually take so many photos. No. This is the photogrammetry tool. Okay, wait. This action is very self-explanatory. By arriving at a specific waypoint, or in this case, many waypoints, it will wait for the set duration of seconds. And you can modify the behavior of your actions by changing the priority. So in this case, I want the drone to wait for 5 seconds at every waypoint. Okay, I want to first set the tilt and then wait at every waypoint. Next, we have point of interest. And then in this case, the drone yaw will be, the drone heading will be drawn to the point of interest. We can set the latitude and longitude coordinates, or we can click here and double click to set the point. So in this case, the change yaw is a conflicting action, so we should remove that. So in this case, the drone during all of this photogrammetry section will be following this point. For example, if we create a circle, we'll talk about a little bit later, but when we create a circle, the set point is set automatically at the center of the circle. What actions next? Set camera mode. In this case, we can trigger photographs at each specific waypoint. So by using shot command, or we can use the start and stop recording button for video. And that's most of the actions. Yeah. For example, for waypoints, we should have additional action. Yeah, this is the LiDAR recording action. So the LiDAR tools have this action by default, but for safety or for any reason, we can add the LiDAR recording on a separate waypoint before and after the main LiDAR area. Or we want to use a different tool for the LiDAR recording. We can do that without problem. Okay, we have been going on with this for 1 hour and 20 minutes. I suggest taking a short 10-minute break. How are you feeling about that?
Yeah, sure.
Okay, is 10 minutes enough for everybody? Okay, then we'll be taking 10-minute break. So at 31 minutes, we can return back to UGCS. Okay, how about everyone? Is everybody present?
Yes, we are ready.
Okay, at this point, before we go further, do you have any questions about what I've told you about before?
Ada mau ditanyain?
No, I think it's enough from us.
Okay, great. Then going from photogrammetry area, the next logical step is the photogrammetry corridor. Basically, it's the same tool, but it's more specialized for long, continuous, and narrow types of missions. This is mostly for the same power line inspections or road inspections, or for any long stretches of area. So for example, we want to scan, for example, this valley, and instead of doing a very complicated area, we can just create a corridor, again, using the same logic as with all other tools. We shape the path, and according to the settings set here, it will generate a path. So in this case, the GSDO5 is not possible. So let's set it at 2. As you can see, it generated 4 flight lines, and if we change the parameters, it might change that. So the photogrammetry tool, well, all tools work on the logic that less is more. So if it's possible to capture this, so the main difference between the photogrammetry area and corridor is, of course, the shape of the tool and the width parameter. So in this case, we know that from the center line, 150 meters both ways, well, I mean 150 divided by 2, 75 meters. So in this direction, and it will capture that width area. So if we set, for example, at 10, then it will create a single flight line at the center, because that is enough. And if we, of course, increase it, then it will create more flight lines. And the width, as you can see, is highlighted by the by these yellow lines here. And of course, the forward and side overlap, the turn type, everything remains the same. One feature of the corridor tool is that since this is a really long stretch of land, let's look at how much. Okay, how do I hide this? Yeah. So here in the elevation profile, you can see that the distance is 8.8 kilometers, and the drone, well, at this stage, it will fly the entire route and then circle back. But this is sometimes difficult to achieve because the drone is flying far away and we need to do a battery change or to remain connected with the RC. In this case, we can choose a specific point or create new ones by clicking on this one. Now we've created an additional point where we can right click and split the route. In this case, we have two separate routes which we can more easily manage. So it will fly from here to here and then circle back. From there, we can change our batteries, do whatever, move to the next location, and start the second mission from here.
Juga di gunung.
And what else with the corridor? Well, as with all tools, I forgot to mention, here's the indicator. This is where the direction angle is. In this case, we don't need the direction angle because we've set the angle just with the center line, but we can move with the cross icon here and rotate the entire route. And if we have multiple tools, multiple segments, then we can use the Control-A command to move them simultaneously. So as I mentioned before, you can, for example, use the corridor mapping tool or the LiDAR corridor to make more accurate terrain following between point A and point B. As you can see, UGCS has generated enough waypoints to adjust for the terrain. A simple waypoint will just take the most, well, will create the route and will create the path in such a way just to avoid the
Biar
obstacles.
nggak terlalu nanjak. Kalau rute biasa, kalau kayak yang tadi koridor langsung kalau kiri.
Okay, this is the photogrammetry corridor. Now let's move to LiDAR area. This is, well, it used the same logic as the photogrammetry, except for a few differences. And those differences is that it's LiDAR. So as you can see, I've created the segment, and the first thing it tells you is that we need to add a camera profile and a camera trigger by distance to capture photogrammetry at the same time. So this is useful if you want to capture a point cloud and take some photos for the texture at the same time. So in this case, instead of using the camera profile or anything like that, we set the FOV of the LiDAR sensor. It is usually specified in the sensor parameters, but the DJI L1 and L2 work in around 70 or 109 degrees. And of course, UGCS will calculate based on that. Here we can specify the flight height, because here well, that's just how it is. and it will recalculate. And here you can choose the camera, which will have additional camera triggering actions to capture that data. And of course, the line spacing, so by site overlap in percentages, or by specifying a distance in meters or feet, or whatever measuring system you're
Kalau
using.
yang itu berarti pakai distance aja. Kalau
And also for LiDAR tools, we have the loop turn angle parameter, which allows you to add a loop. I've been here before.
itunya radius beloknya itu.
LiDAR area. Okay,
Sikunya, siku titiknya ini.
Okay, it might need an overshoot, a slight overshoot for this to work. Okay, I'm doing something wrong here. Let's make the route a little bit higher. Okay, this happened before. What was the problem? Overshoot, speed. Area buffer. Okay, I'm missing something here, but the logic is that it creates a loop. Instead of turning 90 degrees such as this, it creates a loop to fly the tool. The logic is that you can create such loop turns in order to calibrate the IMU during turns. But at this stage, we have added the IMU calibration patterns during the flight. As you can see here, there are blue lines here. We can turn off the IMU calibration and they will vanish. So the logic here is that this was specifically designed for the DJI-L1, but it can be used for other sensors as well. It will accelerate the drone to its maximum speed during the blue line. It will accelerate to its maximum speed, return back to its original position at the same speed, and that will calibrate the IMU. But you can set a large loop turn angle to achieve the same thing. But if you have long passes, even larger than this, then you might need to use the IMU calibration instead. So here it's mostly the same. We have the area buffer, which will extend just for extension's sake, and straight flight after a turn. Also to gain a little bit more data without losing it during the turns, especially since with LiDAR, you don't want to use the stop and turn type because you don't want to stop at the waypoints. In this case, with LiDAR, you mostly use adaptive bank turn to get smooth to yeah, this is the problem. Yeah. So as you can see, these are the loop turns. Yeah. This is the LiDAR area. Nothing too, well, it uses most of the same logic. And with the LiDAR area or LiDAR corridor, which is the same as photogrammetry corridor, but for LiDAR. It has an automatic LiDAR on and off action, which is triggered at the start and end of the LiDAR tool. Okay, what is next? This. Okay, since you're using a magnetometer, the tool that you'll be most likely be using is the area scan tool. It is the same type as photogrammetry and LiDAR area, but instead of relying on LiDAR FOV or the camera profiles, you set the flight line specifications yourself. So in this case, the advanced tab is the same, but in the basics tab, we can specify the simple flight line, the flight height, and the sight distance between the flight passes. So in this case, it's set at 100. Here it is 101 for some reason, most likely because of the turn. And if we change it, we'll get a finer pattern. So next is the circle tool, which I mentioned.
Tapi
It
Maggie
has
jadinya pakai ini si magnetometer.
a poi at the center. And we can do further modifications. Well, the altitude, flight speed, number of laps.
Circle. Jadi
So
dia
let's do
muterin
one
fokus
for
ke
now.
situ loh, fokus ke kalau di fotografi itu nanti misalnya ada dia modeling kayak ada rumah nih kita mau
Okay, let's go with
itu doang yang difokus yang itu doang.
to show this. This is a new addition. So in this case, we create multiple such circular patterns in order to scan something like a tower or a pole or, well, mostly towers, yeah. So any vertical structure which you want to scan with a center point. And in this case, we have added 3 numbers of laps, and we have created 3 separate circle flight paths. And we can change the direction at which they're flown and the spacing between those circles. And the circle is a pentagon because the number of approximating points is set to 5. So if we set it at 3, we'll get triangles. But if we want a standard circle mission, for example, we want to take a photograph at every 10 degrees, then we create 36 waypoints. As you can see, now it is round. And if we want to get very extreme, then we can go for 360 and capture a photograph every degree. But we'll have to set the speed and camera triggering action in such a way that the drone will be able to capture that data. Next is the vertical scan tool. This is used for vertical structures such as building, dams, sides of mountains, and so on. So let me see if I have a model. It's the same thing. Okay, there don't seem to be any models in here. But let us imagine that I imagine that this is a building, and we use the vertical scan tool to fly the drone going up. So in this case, we can set the minimum height and the maximum height. Let's set something more manageable. And UGCS has again created flight lines based on the parameters. So the important ones here are the forward overlap and side overlap or distance. And of course, in this case, for the calculations to be correct, we choose the correct camera profile and the distance to facade. A common misconception is that the distance to facade is it makes the drone fly at a certain distance. But that is not the case because the drone only understands waypoints and it doesn't care about any buildings except for the obstacle sensors. In this case, the distance to facade is set to 50, but it should be, for example, here's our waypoint, and here we have the distance to the building. We can do this inside of UGCS or any other method, but here we have a distance to facade of 3 meters. This is a little bit extreme, but we can still do that. And if we enter it here, UGCS will calculate the camera triggering actions accordingly for auto, but you can remove it and set the distance yourself. For example, every 10 meters. We can control the vertical and horizontal speed, and we can set up the pattern to be either horizontal, such as this, so it's circling around, or we can do it vertical, so the drone is moving up and down. Down and up, yeah, up and down mostly. One thing to remember with the vertical scan tool is that the drone direction is affected by the direction which you're drawing the tool. So these red arrows display where the drone is headed, and because I drew it clockwise, the drone is facing outward, which is useful in some cases for scanning stadiums or dams or any outward structures. But in this case, I want to scan the building. So I need to do the vertical scan tool in a counterclockwise fashion. Okay, where do we go next? Next, we have the various search patterns. They're located here because we don't use them as much, but we have a good client base which required them. For example, instead of using the vertical scan tool for smaller buildings, we can use the perimeter tool to create a simple perimeter and create flight lines according to it. Also set the number of flaps. So in this case, we can set so the drone will fly this perimeter 5 times, and during this flight, we can adjust the camera tilt manually, or for example, well, every route, every segment can be converted to waypoints. So in this case, as you can see, we're going in circles around the perimeter, and each, for example, at the turn here, we can set camera attitude and change the camera angle. And then at the same location, we can change the tilt to something else. And of course, this works with every tool. So if you have the patience, or if you have a very specific problem at a very specific location, then you can convert the route to waypoints and modify the exact problem area. So as we've mentioned with the AGL tolerance, you can use a lot of waypoints. You can generate them to follow the terrain as closely as possible. But for example, if there's one area that is giving you trouble, there's a sudden elevation change and too many waypoints are generated, then you can convert the route to waypoints and either delete some waypoints or modify the speed or change the altitudes a little bit and micromanage around your issues this way. For LiDAR, I forgot about the pattern tool, but it creates such a double circle flight, which calibrates the IMU. You can also, well, you can always decrease the length of width of the circle. Well, it can be squashed like this, or maybe more circular, as it should. And the number of passes. Usually 2 should be enough. LiDAR calibration. And the advanced, there's nothing advanced. So landing will be removed, creeping line. Okay, too much stuff in here. I'm not sure how this tool works because I've never used it, but I assume it's for search and rescue used somehow. If you want, you can check the documentation and see what it does. But a more understandable tool is the expanding circle. This tool I understand. Basically, you set a center point and the drone is spiraling outwards based on the search radius entered here. As I've shown with the vertical scan tool, there are multiple measuring tools. So distant measurement is a ruler. Of course, we can change the altitudes of it to to measure more accurately and change depending on if we want to use it on the ground or relative to the mean sea level. Next is the area measurement tool. Same logic, but for area. So this square here is 2.91 hectares. Visibility range, this, let's go back to Mount Everest. This tool shows the visibility of this point at a certain altitude so that we can understand where the camera, what visibility the camera has. So in this case, the visibility is locked into this region at the altitude of at 400 AGL. Of course, if we put it somewhere here, it's slightly bigger. Because only 10 meters. Yeah, Mount Everest is problematic because it's so big, but it shows you the visibility. But in this case, we see most things because we're on the tallest mountain. Here, for example. Okay, so as you can see, we don't see in this area because we're blocked by this chunk of mountain. And this tool can be used not only as a visibility tool, but to understand where you can lose RC. So for example, if we're having our drone fly this area, the drone might lose RC signal around this blockage. Next are no-fly zones. These are seen as obstacles. We can create prisms. We can name them. So it can start from the ground or somewhere upwards. So like usually NFZs start from 120 where it's not allowed to fly and to infinity. But for some reason, we want to limit our pilots from flying from 120 to 500. Somehow it's not visible. Yeah, right. It's a pretty shape. So this is the NFZ that we have created. And the bottom 50 meters are fine to fly in. And as mentioned before in the route parameters, you can take these zones into account or not. And prism cone. So if you set the top radius or base radius, the height is a little bit extreme. By setting the base radius to 1, the other way around. We can create a cone-shaped no-fly zone. So, for example, if you want to limit flight around certain poles or trees or some cylindrical or cone-shaped objects, then you can put them in there. Also, in future versions, we'll be adding NFZ import and export because some people fly in very dangerous location, so they need a lot of no-fly zones. Okay, the various export options. So this entire mission with all of our routes, no-fly zones, and whatever we have here, the mission can be named here, and we can export it. It is in the JSON format, so missions are can be opened only within UGCS, and we can export also the individual routes. So this doesn't have anything. Yep. So for example, I want to export it, and we can do it also in the JSON format. So we can open the same mission in UGCS as it is. Then we can export it as KML. So we can import it into GIS software like Google Earth, QGIS, ArcGIS, and so on. And quite a few flying apps support the KML format, so we can export the route in that format. But this format is a little bit limited because it has only the waypoint coordinates and altitude. But for most applications, this is fine because we have where we need to fly. And that way we can follow the terrain and capture the needed data set. After that, we just use the native app to set the correct camera interval and camera angle. And the last option is the KMZ export for DJI Pilot. This format also works for newer hotel drones. But basically, you export the file. This is for GPS. MSL is for RTK flights. And then you transfer the file by SD card or however you want, and then use it with DJI Pilot. But you can connect DJI Pilot 2 to UGCS directly, as with our apps. Now we can talk about the telemetry. So here we can play back our flights with all the, okay, where are we? Play back our flights either in real time, or we can fast forward the replay. This telemetry is a little bit choppy because DJI Pilot records the telemetry only, well, sends the telemetry in short bursts. Using our applications, the telemetry is flawless. For example, here. Yes, now it is smooth. And of course, you can import and export the telemetry. So TLM is the native UGCS format and contains all of this wonderful data here, but you can also export it as CSV or KML. But the CSV and KML have their own limitations, but they're more widely supported by telemetry apps such as AirData, AirLink, and some others. And for example, for some very specific flights, you might want to fly your route manually, record the telemetry. So you connect your drone to UGCS, it records your telemetry. You have a nice view of the surroundings. You take the telemetry, export it as a KML file, and then import the KML file back into UGCS so you can reproduce your manual flight, but automatically. Routes. So all routes have further modifications. So select all segments is the same as Control A. We can, so when we have too many waypoints to display, the limit is around 50, I believe. Okay, let's convert this all to waypoints. and still there's a good chunk of. So at some point there will be too many waypoints to display, and at such a point we cannot invert the order efficiently. So in this case, we can use the invert segment order command, and now all segments are flipped. Next, we have the split. We can change, well, we can split by segment, well, how many routes we want, or we can split them by a certain distance. So, for example, every kilometer. And now we have a bunch of routes which are more manageable to fly. Yeah, so they're more manageable to fly. And in case we didn't want to split all of these, well, we split it a little bit too much. Well, we can merge them. So we choose the first route. This is the selected one, and use the second route. Well, we can select the second one route here, and so, and choose which route comes first and which is second. Get native route. This is for PS4 and ArduPilot. So if you're using such a drone, you can use the native app by getting this txt file. It contains all of the commands, and you can also delete the route. Okay, map and elevation data. I've talked about this. And vehicle and payload configuration. So here in the main menu, we can see the My Drones tab. We have all the, well, I only connected these drones to this PC. So they're listed here along with the emulator. So this is the list of all connected drones, and uplink and downlink. This is the drones that we're currently receiving telemetry from. Here we can select what profile it uses and so on, add additional information such as this. And here are the profiles themselves. As you can see, with quite a few, but we can create more of them. So for example, we need a very specific ArduPilot drone. So I don't know, add payloads. We have quite a few of those, but you can also create them. I'll show you how a bit later. And what is one? Platform. And yeah, so basically the profiles contain such information about the battery, what voltage means what percentage, how many GPS satellites are acceptable and how many not, what is the telemetry percentage level, how many waypoints does the drone have, and further drone limitations that you want to input here. For example, maximum altitude. This is only for UGCS. So if you know that you are not allowed to fly above 120, well, you might as well set it and let UGCS warn you when you're flying above that. And more physical properties here just for battery calculations. And as the vehicles, we can select payload profiles here, and of course create new ones. So if you have connected so we have basically a lot of Sony cameras in the profiles, but if you're using a Canon camera, then you'll need to create a custom profile, again with the weight and camera settings of the camera. Most of these are easily found in the camera specifications, except for the true focal length. This you'll need to calculate using an online calculator or just ask the manufacturer. And of course, we can, for example, this one, we can export profiles and then import them back. So you can share these profiles between UGCS users. This is for multi-operator workflows. This is a little bit beyond basic. The configuration, here you can configure your VSMs. For example, if you're using a lot of drones or multiple UGCS instances, you might need to specify which VSM you would like to connect to. For example, the DJI VSM, you can set up the host address of the remote controller and make sure that the connection is stable. Languages, the measurement system, and many other. For example, the once in a while we release new features, but because we didn't test them enough, we have added them here so the customers can test them if they want to. And of course, license, again, activate, deactivate. Okay. Telemetry we did. So the UGCS for DJI application, this is one of our drone flying apps. So you do the flight planning in UGCS and you need to get that to the drone somehow. With DJI drones, since they have their own autopilot and their system is closed, we need to use intermediary apps to send our missions to the drone. In this case, for older drones, well, basically the M300 and older, we use UGCS for DJI. It looks basic like any other flight app. And, well, the gist of it is that you connect to the same network. The most practical way is to connect to the same Wi-Fi network. It can be from a mobile router or hotspot. And then UGCS and UGCS for DJI understand each other, and you can send over your flights. The same can be done with newer DJI drones using our DJI companion app, UGCS companion app, and with DJI Pilot directly. Since you're using the M300, I recommend using the UGCS for DJI app since it has the most complete set of features of UGCS. But if you're using, for example, the DJI M350 and you're using a magnetometer or any other advanced sensor, so DJI Pilot is not the best solution for it. It's mostly for photographic commands. In that case, you can use UGCS Companion to fly your UGCS missions. If you have your drone with you, I can help you with connecting your drone to UGCS. But again, in the documentation at manuals at UGCS.com, the process is very simple, as well as we have multiple YouTube videos on how to connect all of our apps. So next we have how to use UGCS without an internet connection. Once again, we need to activate UGCS. Before that, we need internet for that. So let us imagine that we don't have any of these digital elevation models, for example, in files, and all of the data, for example, from Google Hybrid and from SRTM, they are taken from the internet. So we need to we need the internet to plan our missions. Since that is not always possible, we can click the right mouse button, choose offline map, and create, for example, we can save this region for offline use. But this region is ridiculously large, So 31,000 square kilometers is, I don't want to waste so much this space. So for example, we plan to fly in this approximate area. We select the map that we want to save, since we can also cache the visual map, and select the elevation that we want to save. Click on create. And depending on the power of your PC and the amount of data, this might take a while. But now to save, then you can turn off the internet and plan the mission within these boundaries without any problems. Also within UGCS for DJI, if you're not using it on a DJI controller, you can load all of these maps using UGCS directly to the controller, so that you can monitor the flight on the controller with more accurate and recent data instead of the one that DJI provides. And of course, I think this is understandable, is that if you plan to fly away from civilization, get yourself a good power source. So it may be a generator or a portable power station to keep all of your devices powered on. Next is UGCS Mapper. In case you don't have photogrammetry software, we offer one for you. It works in a very simple manner. You select the folder with your images and where you want to save the external data. And then, you do some calibrations depending on the camera and drone, but it is only done once. And then you'll get an HTML report with all your data and a short summary of it, and you get an orthophoto, which you import into UGCS, and a digital elevation model, which you can also import into UGCS or use in other projects. And for compared to other apps, you can click just the publish button, and the data from Mapper will be loaded to the Geo server, which is accessible by UGCS. If you're using any other map processing software, then please remember that these elevation sources use WGS84 with EGM96 heights. So if you don't want the same situation as this, where you have a large gap in elevation data, use EGM96 elevation, and then it will be mostly correct. Okay. Any questions?
Okay, I want to ask about the recording for the magnetometer sensors. On the photogrammetry tools, we can set for each waypoint when we can turn on and turn off the recording of the camera, but I don't see that option on the area scan mode. So the only thing I saw how to record the magnetometer is using the custom payload monitor. Or is there any other way to do it on the UGCS?
Unfortunately, I don't think so. I might be wrong, but the magnetometer, among many other sensors, they're just not compatible with the drone autopilot, so we can control them via UGCS. So they are controlled via the CPM and the SkyHub.
Okay,
or
so
if it has its own logger, then does it on its own. For example, we used to have LiDAR sensor profiles but we stopped using them because many LiDARs don't have a PSDK connection to the drone. So there is no point in using those profiles, and you just have a physical button where you press it to start and then press it again to stop. So for many sensors, it has the same logic. But regarding this, you'll be taught more on the next training, which I hope you have.
Okay.
Anything else? I went through the program, and I'm not sure what else to specify. Well, there are many things, but this point, I would suggest before the information is still fresh in your heads, I would recommend playing around with UGCS at this point. Use the emulator as I did during the presentation. But if you have the drone with you, you can try using the simulator tool to fly the routes that you would like to try. So for example, with UGCS for DJI, you're using the M300, right?
Yes, and actually I have the drone set up right beside me.
Mm-hmm. Well, if you want, we can connect it.
Okay. Okay.
Mohammed?
Hello. Yeah.
Hello?
Hello. Yeah.
What controller are you using?
DJI RC.
RC Plus or Smart Controller?
The regular RC.
Well, there are many of them. Basically, is it a long screen, like 16 by 9, or is it more squarish?
Okay, I'm not sure about the type, but if you can see on the video.
The smart controller, yeah.
Okay.
So in this case, you can use UGCS for DJI
Okay.
without many problems.
Hmm.
As I see, you have UGCS Companion on there.
Yeah, it's set up.
But if you're not using the camera, both apps they work just fine.
Okay.
It's just that with UGCS Companion, you cannot set up the simulator within the app, but with UGCS for DJI, you can look up at our documentation and create a simulator without connecting to the DJI system. So now if you have UGCS installed, all you have to do to connect the drone and RC is to turn everything on and connect to the same Wi-Fi network.
Yep, I already done that.
Yeah. And if you want to simulate the flights, it's just that emulators are nice and all, but it's based on ArduPilot, and all drones have, well, depending on the firmware and specific models, all drones can be a little bit different. So in this case, you can set up a simulation with UGCS for DJI and try flying the routes that way before flying for real. But at this point, I am out of material to teach you. All of this entire recording is accessible, well, will be accessible via a link. You'll be provided with a passport, so you can download this recording and catch up on some things you have questions on. But for most problems you might have, well, the documentation is a great tool. But in case something unique is happening to you, then you can contact us at support
Okay,
at
yeah.
ugcs.com.
I think we need some time to tweak with the UGCS. I mean, yeah, we need more time to tinkering.
But it's a very powerful software, and that's
Yes.
its drawback, that there's so many options you can do, and people, well, most people don't need that much control. But for the professionals, it's pretty great. Well, in that case, we can end our session.
Oh, ada meeting lagi?
Then, if you don't have any more questions, we can end for today.
Okay, I think that's enough.
Okay, then, it was fun having this moment with you. So, bye for now.
Okay, bye. Thank you.
Bye. You're welcome.